Congratulations, you've made it to the last lesson of this unit and of course the last part of the foldable. This should be pretty easy to find. It's the only one we haven't done. The definition of a kite. What is the definition of a kite? Well, it's a quadrilateral. Point that arrow back so you know that's got 360 degrees in all the angles. And it is distinguished by having two sets of consecutive congruent sides. That's a mouthful there. Let's talk about what that means. It's got two sets of consecutive congruent sides, and we know that consecutive means connected. So sides that are connected and equal in length, like these two right here at the top, and then these connected sides down at the bottom, these are equal in length. And it's called a kite because it looks like a kite, the kind you fly. Open it up and let's look at two special properties. These are the ones to know. First special property of a kite, and write this down. One diagonal is a perpendicular bisector of the other. Let's draw in the diagonals and show that. So we've got two diagonals, one of course coming this way, one coming across this way. One of them is bisecting the other one. And you can see from the diagram, this guy has two equal pieces, and it's doing it at a perpendicular or right angle. So we've got these matches. The second property of kites to know is that it forms two congruent triangles. Now it refers to the diagonals. Okay, so this guy, that guy is forming two congruent triangles, and that's going to be important because that means that we've got a lot of equal parts here. Like on this one, this angle right here is going to match this angle here on the other side, like a mirror image of it. This angle, if this is say 20 degrees, well, that doesn't even look 20 degrees. Let's say it's 70 degrees. Make that a 7. 70 degrees here, then it would be 70 degrees on the other side right there. And the same down here. Let's say this is a 15-degree angle. This is a 15-degree angle. So there's some matches there going on that diagonal. Let's look at examples for this. Find these angles. So you can see the tick marks. These sides connected. Make it a kite over here too. And first of all, this angle in the middle is a 90-degree angle. You're going to want to mark that. That'll give you angle 1. Angle 1 is 90. And that means we've got some right triangles. Let's just go one triangle at a time. How about we look right here at this triangle? There's a 90 on all four of these corners. And so what is that going to tell us about this triangle? Let's add up what we have. We got a 90-degree angle, a 53-degree angle, and our last angle we're calling angle 4. So that's going to add up to a triangle total of 180. So our angle 4, if we subtract off, what's this total? 143. I think we're going to get 37 degrees for angle 4. And we can do that same sort of thing over here. Let's do angle 2, for example. Angle 2 right here. So we've got a 38 and a 90 plus angle 2. Same idea. 38 plus 90 plus our angle 2. We'll make a 180 total. So what is that going to give us if we subtract off the angles we know, which is 128 degrees. So I'm thinking we get 52 degrees for angle 2. I'm going to put those in. So angle 2 is 52, and angle 4 over here was 37. What's angle 5 going to be? Let's just find matches for angle 5. So angle 5, he matches this angle right here. So the angle 5 is 53. And over on this side, angle 3 is a match to the 38-degree angle. Those guys are just a matter of looking at the congruent triangles. Love it. I like doing the angle ones. Let's see how we get another angle 1. Okay, so on this one, we get angle 1 and angle 2. And there's a couple of different ways we could do this. I'm thinking that I'm going to draw in a diagonal. I'm going to draw the diagonal that splits my kite into congruent parts right here. So that means angle 2 and angle 1 are the same, and it also means that this just got split or bisected. So that 90 just made two 45-degree angles, and it also split down here this 48 into two equal parts, so just dividing by 2 I get two 24-degree angles. Angle 1 and angle 2 are just the third angles of those. So let's look at angle 2. I have a 45-degree angle and a 24-degree angle all in that triangle, and angle 2 is making up the last angle there, total of 180. So how many degrees in angle 2? Let's subtract away, this is 69. So take 69 out of 180, and you get 111 for angle 2. 111, and angle 1 down here is a match. It's just a congruent triangle. So they're both 111. That's one way you could do it. Maybe you can find a different way. See if you can. All right, more angle information. And again, this is a kite. You want to look for these tick marks on connected sides and make sure you have two sets of those. So that means that we've got some angles that are the same. Namely, right here, this angle I'm going to mark, and on the opposite side of it, this angle, because these are two congruent triangles on each side. So that means I can set those equal to each other. So my 3x plus 5, I'm going to set that equal to the 4x minus 30. Let's find x. How about we take away 3x's from both sides so that we can get them together? Yeah. And let's add 30, putting it over here. Those are gone. So we've got 1x on this side and we've got 35 over here. So the value of x is 35. How about y? Well, what can we say about this angle for angle y and this angle right over here? Don't be tempted to say they're equal. Remember, your equal matches are on the opposite side of your vertex of your diagonal. So right here, these are a match, and over here, these are a match, but not across the way. So instead, what could we do? We could take the 2y minus 20 and we could put it in this spot, and that'll get us into a triangle. We could have all three of these angles. It would be pretty nice to know what this angle measure is. So let's take our x value of 35 and let's plug it in and find out what this measurement is. Let's just do that right now. So we've got 3 times by 35 plus 5 more for this angle measure. So we multiply that out. 3 times 35 is 105, and add 5 more. We've got a 110-degree angle right here. Let's just go with that triangle and add the 3 angles up. In fact, let me highlight the triangle so you see the one I'm talking about. Let's take the 3 angles of this triangle up at the top here. Come over here and give me some room. So our 3 angles of the triangle, one of them is y. And then let's add in the one we just found right up here in the top is 110. And our last angle is 2y minus 20. So we'll add that in. And it's a triangle. We've got 180. We've added all the angles. So now we're just ready to combine the like terms and solve this. On the left here, we've got 3y all together. And 110 minus 20 brings it to plus 90. And so let's take away the 90 from both sides of that. And we're at 3y equals 90, dividing by 3y comes out to be 30. Okay, so y is 30. We found the value for y. Let's just go plug it in and make sure. What right here is 30, and right here would be 2 times 30 minus 20. That's 60. This is a 40-degree angle. So does it add up? 30, 40, and 110 gives me 180. Hope you get 180. Alrighty, our last example. Let's find in this kite the distance from K all the way to T is 8. It's going to be hard to mark. How about I remember this is a bisected diagonal, and let's put 4 and 4 on each side. Split it equally. Now K to I is 5, and K to E down on this side is 10. What are we going to be finding? We're going to find the length of our diagonal from I to E. How do we do that? This is the trick. You need to remember there's a right angle in here, and we've seen this a lot in this unit already. Right triangles, finding side lengths, Pythagorean theorem. So let me do this. Let me take KI, and that point doesn't have a name, but this little triangle right here, let's just redraw it. There's a right angle, there's a 5 and a 4, and let's figure out this little part of it, x. We'll call it x right there. And that's my plan. And my plan for the second part of this is with this triangle, this longer one, I'm going to do the same deal. This has got a longer piece with a right angle. This is 4, 10 right here. We're going to call this y and find that. And then I should be able to just join those together for my full diagonal length. Got the plan? Okay, let's carry it out. Here we go with our blue triangle. A squared plus b squared equals c squared. So our right angle is here. That makes 5 the c. So 5 squared on that side by itself with x squared plus 4 squared on the other side. We solve this. This is x squared plus 16. We got 25 there. Let's take away the 25. So x squared by itself would be just equal to 9. And when you square root 9, you get 3. That's the value for x. X is 3. Let's go put that in your picture. Okay, let's do the same deal for the y. So on our triangle down here, our hypotenuse is that 10. So we're going to put the 10 all alone squared, y squared plus 4 squared on this side. Let's calculate it. Simplifying, we get y squared plus 16 is equal to 100. And when we subtract 16, we get y squared by itself is 84. So we get to square root 84 for our value for y, which comes out to be, grabbing my calculator, I know it's a little bigger than 9, but let's see just what it is. Square root of 84 is 9.2 in rounding it. So 9.2 for y. Cool. All right, we have enough to answer the question now. And the question, remember, is the full diagonal from I to E. We want to add and join those parts together there. So our final answer is going to be I to E is the 3, the part at the top, plus the 9.2 at the bottom for a grand total of 12.2. That's the kites.